Hello, my name is Mac O'Leary, and this is Physics 2211 Lab Report number 1. So, the purpose of this lab was to gain insight into the kinematics of objects moving without a net force. So, Newton's first law, an object in motion will stay in motion unless acted upon by a net external force. So, in order to do this, we took a marker and we rolled it across a table, and we had a ruler nearby and we recorded that. So in order to complete this lab, we had a ruler and a marker and a camera, of course. And then as far as software went, we used the tracker app to calibrate and collect the data on the marker's position versus time, and GlowScript Python in order to create models to simulate this situation. As far as the results of the lab went, there was a slight amount of error. This was most likely a result of the marker sliding across the table after it was flicked instead of rolled. This caused the marker to slow down slightly throughout the course of the experiment or video, which is why the results do not exactly match to the expected. So, methodology for this lab. The central idea was to measure and track an object moving in one dimension with no net forces acting upon it. So to prove or disprove Newton's first law of motion. As far as assumptions went, we assumed that the marker is moving with no net forces, net external forces on it, because the marker was expected to roll without slipping, which would be a frictionless environment. We also assumed speeds aren't relativistic, but that doesn't really matter. The system and surroundings. So the system in this instance was the marker, as that was what we were tracking the motion of. The surroundings are supposed to be nothing, but you would have to consider the force, the normal force from the table and the force of gravity from the Earth, but those cancel out, so there's no net force from that. You additionally, as you'll see, because the results did not exactly match the expected, there was some net external force, and we assumed that this was the table, which created some sort of friction on the marker. For the experiment, we rolled the marker across the table parallel to the path of a ruler, and then we plugged this information into the tracker application where we collected data on the position of the marker, and from there we exported that data into a spreadsheet for analysis. As far as the coding, it was a simple Newtonian velocity position update model. There was no net force, so the velocity didn't change throughout the experiment. And additionally, there were 100 iterations per second, so the system was updated 100 times per second. We went to 100, so that means that 122 iterations were calculated. The model also created graphs for the position and the velocity, and a model to show the trail of the. For the initial velocity condition, we assumed a velocity of 3.12, which was collected from the spreadsheet of exported data. Next up, the measured data versus the expected data. You can see that both have a positive velocity, however there is a significant downward trend in the velocity of the measured data, while the expected data just has the velocity remain constant. This means that there was some net external force resisting motion, and which was likely friction. The conclusion of this lab, so this experiment sought to measure the motion of an object without any net external forces to show Newton's first law. This was expected to create a situation where the velocity of the object would stay the same throughout the course of the experiment. However, that was not what actually happened because the marker slowed down. So this experiment is inconclusive in terms of showing that Newton's first law holds true, as the marker did experience some net force. Thank you.